Hello everyone, today we're looking at perhaps the most useful part of my grind last year, and that is 2018 Feburary Teleportation. And as we can see, we're doing another silver problem, but trust me, this is actually good. So we're talking about basically like a math problem, and it's like a function kind of thing. We have a bunch of manures that we have to move from point A to point B. There's at most 10 to the fifth power of them, and then you can also build a teleporter that has a starting coordinate, and you're trying to find the optimal ending coordinate so that the sum of the distance you have to travel moving the manure is the least, and it doesn't cost any to use the teleporter. So if you move a manure to the starting position, it immediately teleports to the ending position. So yeah, now you can pause the video and think about this yourself. Okay, so this problem is almost the exact same as the 2025 January. And I did this just in the right time that I was able to actually remember this problem and look back at that to help me solve this one because it was literally almost the exact same algorithm. And I'm so surprised to find that not only did USACO official solution not mention this, the community on Luogu, which is the biggest coding website in China, no one noticed this, and no one on YouTube noticed this. But like literally, I used almost the exact same algorithm for these two problems, and this problem was considered pretty original by almost everyone except for me, who realized that a problem from exactly 7 years ago had the exact same solution. Anyways, let's jump right in. And also, I strongly recommend you guys read the comments in which I'll be posting this entire code, and I have the full solution here, which I'm not going to read now because it's way too long. But essentially, the idea is, first of all, I tried ternary research, but obviously this is not a unimodel function because even though each of the cost of the ith manure removing is unimodel, combine all of them, it is not. However, if you can notice that the function for the cost needed moving the manure with x coordinate being the value of y and y coordinate being how much you need to move them, you get a new unimodel function that's like this. And notice that it's actually four linear functions. The first part in which you don't use a teleporter at all, the second part in which the teleporter gets closer and closer to the optimal position until right here where y equals b, and finally after the teleporter gets way too far away that you don't want to use it anymore. And notice how we can keep track of all three breakpoints actually. And I mean, well, it's four breakpoints, but it doesn't really matter. We can keep track of how the slope changes, and notice that the optimal answer will only occur at some breakpoint. And there's only 4 times n, which is 4 times 10 to the 5th power breakpoints on the n graphs. So if we just keep track of that, and for each distance we move, we can just use the sum of all the slopes times how much we moved in terms of x coordinate to quickly find what we will be in the y coordinate at that breakpoint. So this is my code for this problem, and it's almost the exact same for the other problem in January, the 2025 Farmer John's favorite operation. So I mean, either USACO is just trying to reward us grinders who does every single problem, literally every single silver from 2018 or even earlier. I think I finished. Either USACO is trying to reward us, or they're just really dumb. And Chong Tian Ma did not look at Brian Dean's problems. Anyways, yeah, this just proves how much it helps to actually grind. Like if you grind 10 hours a day and finish every single problem in the same division for the past 10 years, you're probably gonna get a problem right on this next contest, even though you might not get promoted. I didn't get promoted in January, but I mean, it did also boost my ego by a whole lot, because if I hadn't done this problem, I wouldn't have been able to solve this one, and I would have just ended with maybe like a 333 on this contest, which would have been really bad and hurt my ego a lot because I grinded, and if I not even get 600, that will be quite embarrassing to myself and everyone. So it just proves how much it helps to grind. Anyways, that is it for this problem. Really smart strategy, and the only two problems I've seen use this strategy is this one and that 2025 January one. So I guess I'm either just lucky or the fact that I did everything just rewarded. Anyways, thanks for watching. See you tomorrow. Okay, for the grind report today, I didn't really grind again, but I did solve one problem. It's test for hay bales, which is 2022 January, I believe, and it's actually a really good problem. This just shows how different gold is from silver. I mean, aside from the fact that when you grind for silver, you don't wake up at 2 p.m. and then spend only 3 hours a day grinding when you have nothing else to do. Other than that, just talking about the problems itself, gold almost never gives you what you want in the input. Like in this one, I had to increment the input all by exactly 1, so it's a lot easier to think about. And also in gold, there's some ridiculous ideas that you have to turn into rational ideas. In this problem, we can build a tree, obviously, and then we approximate what the thing will be, and then realize that we just have to add a value to make the approximation precise. So to turn this hunch of intuition into formalized thing, we have this, and then we have that, and then we do all that, and it's just classic gold. We have almost no difficulty implementing, but it takes about 50 minutes to get through all of this. And obviously, I was not even able to get through step 1, but I was able to after looking at the solution. So yeah, and I also wrote 2 solutions on Logu today, so like 3 hours grind now. No, terrible, but what can I do?